By many measures, Mwmbl is doing great. We've indexed over 500 million pages, we have over 4,000 registered users, and over 30,000 creations from those users. Our volunteers are crawling around 5 million pages a day. But the score that I care most about right now is NDCG. This measures the quality of our search results against a gold standard, which is just Bing results for the same query. Obviously, we're not ultimately aiming to be like Bing, so eventually we'll stop using Bing and start using our own curated data once we have enough and the quality is high enough. But we are far enough away from being good that moving in a Bing-like direction is great for now. Because our NDCG score is pretty poor, a score of 1 would be matches Bing exactly, while a score of 0 would be nothing in common with Bing. We are scoring 0.336 on our test set. However, most of that comes from sticking Wikipedia results at the top by querying Wikipedia with their excellent API and using their ranking. Without that, we were scoring 0.059. Using Wikipedia alone, we'd score 0.297. I've experimented off and on with learning to rank. This was the industry standard for ranking before large language models came along, so it seemed like an obvious place to start. Implementing a lot of standard features improved the results slightly over my original intuitively defined features, but still only gave us an NDCG score of 0.365. Nevertheless, after trying for a while to improve on this further, I decided to deploy this ranking instead of the heuristic that we were using before. It didn't seem to make the results worse, and it seemed to be fast enough, at least on my local machine. I didn't realise it at the time, but this is when things started breaking. You see, we only have one server. We don't do actual crawling on the server since that is done by volunteers, but we have to process the crawl data to find new links, prioritise those links for crawling, pre-process the data for indexing, and index it, as well as serving search results, all on one server. And it turned out that adding a ton of features and using XGBoost for every single search query added enough load to the server that things started to slow down. Even loading the main page could take 3 or 4 seconds. At the time, I didn't realise that this was causing the problem since a bunch of other stuff was happening. We had some enthusiastic volunteers that were crawling many millions of pages a day. Search got so slow that I decided we had to turn off the crawling. I made the server that sends batches to crawl return an empty list. I turned off the scripts that update the crawl queue and index new pages, and things got better. But they still weren't as good as they were before. It took me a long time to realise that it was the change in ranking that was the problem. In retrospect, we should have had better monitoring around everything so that we could more easily identify the cause of the slowdown, but this is a project that I do for fun, so I've put off doing this kind of thing because I find it boring. Boring is not fun. But a broken website is also not fun. You live and learn. Now I've changed the ranking back to the old heuristic and turned on the crawling again. I still think learning to rank has potential, but we can't afford it with our current resources, so I've started looking at alternatives. What would make ranking almost infinitely scalable if we don't do it ourselves, but get our users to do it on the client side? This works really well for us because we don't rank like a normal search engine. Our results are already ranked for each unigram and bigram query. We pull out the pre-ranked results for each unigram and bigram in a user's query, then re-rank them using our heuristic. This is perfectly feasible to do on the client side since we don't have more than around 30 results per unigram or bigram on average. It also gave me the final push I needed to implement ranking in Rust. I know that Python is a bad choice for a search engine, but I chose it because I knew I could build something quickly, and that I'd probably give up at some point if I tried to do it in Rust. Yes, I know Java and C++, which would have been fine choices, but they would not be fun. This project has to be fun, or it will not happen. I'm a beginner in Rust, and doing 2 hard things at the same time, building a search engine and learning Rust, seemed like a recipe for disaster. But I can build small bits in Rust, especially if I have already built them before in Python. So, over the last few days, I've rebuilt our heuristic ranking in Rust. The Rust compiles to WebAssembly, which will eventually be called from our excellent new front end. The WASM file is currently 1.3 megabytes with optimizations turned on, which is larger than I'd like. Gzipped it is 491 kilobytes, which doesn't seem too bad. And the client only needs to load it once until we change our ranking algorithm. It's likely that we'll still need to do some ranking on the server side for low-power devices and possibly API clients. But with client-side ranking, all the backend needs to do is pull out pre-ranked search results for each unigram and bigram. These can be easily cached and potentially even kept in cloud storage. If we're ever going to serve millions of users on our shoestring budget, then this is how we'll have to do it. If you'd like to get involved, join us on our Matrix server or send a pull request to fix my rubbish Rust code. Thank you for listening.